The first order of business in task 5 is going to be to try to figure out how many different ways we can complete the brackets for our 64 team NCAA tournament. So that question, jumping right into it, might be a little bit tricky. So we'll start with some easy stuff. We'll do some inductive reasoning, and from that, maybe we'll be able to figure out how many ways the brackets can be completed for a 64 team tournament. Start with the super easy question. In the case of 2 teams, how many games have to be played to determine a champion, and correspondingly how many different ways you could make the brackets for such a tournament. So here's a 2-team tournament, single elimination. Obviously one possible outcome here would be that team 1 comes through to be a champion. Only takes 1 game to play out that not very exciting tournament. What's the other possibility? Well, the other possibility would be, instead of 1 winning the tournament, team 2 wins the tournament. So again, just a single game tournament, but there's 2 possible outcomes. So I can go back and tabulate that data, start looking for patterns. It takes 1 game to determine a champion, and either 1 or 2 wins. So there's 2 different ways you could complete those brackets. We'll look now at a 4-team tournament. What I'd like to do maybe is just look at different scenarios where the 1 seed comes through as the champion. That can happen like this, where high seeds win throughout, or it could also happen like this, where 3 pulls an upset in the first round, 1 meets them in the championship, and then 1 comes through as the champion. So that's the number of ways that number 1 could win the tournament. There's no other possibilities for 1 to win the tournament. It can happen 2 different ways. Notice that as I'm going through this analysis, I also want to kind of keep in the back of my mind how many games need to be played in such a tournament. So we had to play 2 first-round games and then a championship game. So there's 3 possible, or 3 games needed to figure out who the champion is in this kind of tournament. You can use similar reasoning to go ahead and figure out, okay, how many different ways would there be for number 2 to win the tournament? And you'll see that it's the same. There's 2 different ways that that can happen. Likewise for 3 or 4. And so you can see in this situation, if you have a 4-team tournament, the number of ways that you can fill out the brackets is 8. And I don't want to diagram all of those, but you can go back and convince yourself if you don't believe me. Okay, let's tabulate that data. So like I said, in a 4-team tournament, it takes 3 games to determine the champion, and there's 8 different ways that you can complete the brackets. To diagram a 8-team tournament is really tricky. So before I jump into that task, I want to go back and look at the 4-team tournament. Look at it more specifically in terms of the number of games that are needed to determine the champion. Kind of already looked at the idea that you'll have a first-round game here, first-round game here, and a 3rd championship game. And so it just takes those 1, 2, 3 games to determine the champion. So game 1, game 2, game 3, then a champion's determined, tournament's over. What I want to figure out is, for each of the games that I've put up here in red, how many possible outcomes are there? Well, when the 1 plays the 4, either 1 wins or 4 wins. So quite simply, there's 2 possible outcomes. Looking just at this game, the 2-3 matchup, either 2 wins or 3 wins. Again, 2 possible outcomes. And once you have the 2 teams coming through to the championship, no matter who they are, either the team coming out of the top side or the team coming out of the bottom is going to win. So there's 2 possible scenarios there as well. By the math counting principle, we can figure out the total number of ways that you could fill out these brackets by just multiplying these individual outcomes to 8 different possibilities. Notice that this is the same thing that we already figured out in our table back here, and we were actually kind of diagramming out the brackets. We'll use a similar analysis to figure out how many different ways we could complete an 8-team single elimination bracket. So as before, we'll begin by figuring out how many games must be played to determine the champion. You can kind of already see underneath here that that's going to be 7 games. Just to see those, maybe I'll number them here. We have 1 game here, 2, 3, 4. So there's 4 first round games. Moving into the next round, there's a game here and a game here. And then there's the 7th game, which is the championship game. And after that, we know who won the tournament. So 7 games. Each of those games, how many different possible outcomes are there? Well, in the 1-8 matchup, either 1 wins or 8 wins. So there's 2 possibilities there. Same thing for the 2nd game, 3rd game, 4th, 5th, 6th, and 7th. So if I'm trying to figure out how to turn all of these individual outcomes into the total number of possibilities, what do I have to do? Well, once again, by the counting principle, all I have to do is multiply these individual outcomes together. So it ends up being 2 to the 7th power, which ends up being, is that 128? I believe it is. And so I'm going to go back and tabulate that. 8-team tournament takes 7 games to determine a champion. 2 to the 7th power is 128 ways that those brackets can be filled out. You can see why I certainly wouldn't have wanted to diagram that situation, because 128 scenarios would take a long time to diagram. And then, of course, like it says on your handout, what you're ultimately working for is a 64-team tournament, and how many games it takes to determine the champion there, and how many different ways you can fill out the brackets in that situation. Good luck. Ask me if you have any questions.